Hello there, and welcome to our channel, where curiosity settles in softly, and the mysteries of our planet drift through the quiet like snowflakes in the night. Tonight's story is a little colder than usual, but perhaps just as comforting. It's about a time when the world you know, with its forests and cities and sunlit seas, looked utterly different. There were no trees, no animals, not even green continents, just ice. Endless, gleaming, unbroken ice. Imagine the whole planet wearing a white coat so thick it turned even the equator into a frozen desert. That was Earth, once during a period scientists call the Cryogenian, when our home may have become the biggest snowball in the solar system. Before we set off into that frozen world, I wonder, what's the temperature where you are right now? Is it warm where you're listening? Or can you feel a bit of winter in the air? Maybe it's night and you're wrapped in a blanket, or morning with steam rising from a mug nearby. Either way, thank you for joining me here, for taking this quiet moment to look not out a window, but far back in time, to an age so long ago that the moon looked the same, but everything beneath it did not. If you find comfort in these soft wandings through science and story, it would mean the world if you left a like or subscribed or shared this calm little space with someone who might enjoy learning before sleep. It helps more than you'd think. Now take a slow breath. Let your mind settle and picture the world as it once was. Not blue and green, but white and silver and silent. The Earth of that distant age was more than 600 million years removed from the one outside your window tonight. Continents were clustered differently, drifting slowly across a planet that had long since cooled from its fiery youth. Volcanoes still breathed fire, but life had not yet ventured beyond the oceans. What little lived then was microscopic, simple, resilient, mostly unseen. If you could have stood on land and somehow survived the cold, you would have seen no plants, no grass, only bare rock and the glitter of ice sheets stretching toward a horizon that looked almost metallic beneath the dim sun. The sky might have held a faint bluish haze, thinner than ours, because oxygen was still scarce. There was carbon dioxide, methane, nitrogen, and the faint ghost of water vapor freezing into delicate clouds that barely moved in the still air. This wasn't how Earth had always been. For billions of years before the Cryogenian, the planet had been warmer, sometimes oppressively so. The young sun, though dimmer than today, had been balanced by thick greenhouse gases that trapped enough heat to keep the oceans liquid. Stromatolites, layered mounds built by colonies of microbes, thrived in shallow waters. They were among the first great builders of ecosystems, long before plants or animals appeared. But even their slow, simple activity changed the atmosphere. Over eons, they exhaled oxygen as waste, gradually stripping the air of carbon dioxide. Volcanoes replenished some of it, but the balance shifted when the continents began to move. New mountains rose, rocks weathered, and more carbon dioxide was drawn out of the sky through chemical reactions with rain and minerals. Slowly, imperceptibly, the blanket that kept the planet warm began to thin. It didn't happen overnight. It might have taken millions of years for the tipping point to arrive. A chain of small changes that led to one of the greatest transformations in Earth's history. Scientists think it began when the supercontinent Rodinia started to break apart. The splitting of land opened new coastlines where rainfall and erosion could pull even more carbon from the air. Meanwhile, The distribution of continents closer to the equator meant that bright ice could form there more easily, reflecting sunlight back into space. That reflection, called albedo, is powerful. The more light that bounces away, the cooler the planet becomes. The cooler it gets, the more ice spreads, which reflects even more light. And so, the spiral continues. It's a feedback loop, one that doesn't stop until something else interrupts it. At first, the cold might have been regional. Glaciers advancing from the poles, seasonal snow lingering longer each year. But eventually, it crossed a threshold. The oceans began to freeze. The line of frost crept outward until even tropical waters were capped by thick ice. Beneath the frozen surface, there may have been pockets of brine, where simple organisms continued their slow dance of survival, feeding on the faint chemical energy that seeped up from the seafloor above them. The surface turned into a mirror so bright that sunlight struggled to penetrate. It's strange to think of Earth like that, not blue and full of motion, but pale and still from space. It would have been dazzling, almost too bright to look at, a white marble in the dark, shining against the velvet of the cosmos. The clouds that once drifted lazily would have vanished, replaced by a high, thin mist of ice crystals. The atmosphere itself may have been quiet, with winds diminished by the lack of heat differences between regions. Even the usual hum of the planet, rain, waves, storms, would have been subdued. For life, such conditions were catastrophic, but not entirely fatal. The earliest microbes had already adapted to extremes long before. Some may have found refuge in cracks within the ice where faint light could still reach and melt small channels of liquid water. Others could have survived near volcanic vents, feeding on chemical gradients where their crust met the ocean. The story of life on Earth, as it turns out, is not just one of flourishing, but of endurance. The evidence for this ancient freeze lies hidden in rocks that were once seabeds. Geologists have found layers of glacial debris, dropstones, boulders, carried by ice and dropped into soft sediment in places that were near the equator at the time. These stones, frozen into ancient mud, tell of icebergs drifting across oceans that should have been warm. Their presence so far from the poles was the first clue that the Cryogenian was not just another ice age, but something far more dramatic. It took decades for scientists to piece together the clues. At first, the idea that the whole planet could freeze seemed absurd. After all, how could life survive? How could the cycle of carbon and water continue if everything were locked in ice? But more evidence emerged. Chemical signatures in ancient rocks showing sudden changes in carbon isotopes, marks of a planet struggling to breathe. These signatures, found on every continent, point to global events rather than local ones. The conclusion, though still debated in detail, is clear enough. The world nearly froze to death. Imagine what it might have felt like to witness the beginning of that transformation. The seas, once dark and restless, gradually calming as ice spread across their surfaces. The light dimming not from clouds, but from the sheer whiteness of the earth reflecting the sun away. Each year colder than the last, the horizon creeping closer as snow buried everything in sight. Rivers solidifying into ribbons of glass, mountains crowned in ice that never melted. Perhaps the last patches of open water steamed faintly in the cold air before sealing shut. A hush would have fallen over the world, not the silence of peace, but the silence of exhaustion. Yet even in that stillness, something extraordinary was happening. The planet wasn't dead. Beneath kilometers of ice, geothermal heat continued to rise from the mantle. Volcanic islands still erupted here and there, releasing gases that could not easily escape the frozen air. Over millions of years, those gases, carbon dioxide above all lower bind, began to build up. Slowly, the invisible breath of volcanoes started to thicken the atmosphere again. But for now, in this frozen dawn, that warmth was only a promise. The Cryogenian period is divided into two main glaciations, the Sturian and the Marinian. Each may have lasted tens of millions of years. Between them, there might have been brief thaws, but the world never fully recovered until the very end. To put that in perspective, the last ice age that shaped human evolution lasted less than 3 million years, and its coldest stage is only tens of thousands. The Cryogenians' reign of ice was on a scale almost beyond imagination. The air would have been thin and dry, the ocean surface sealed, the sun a weak disk in a pale sky. The contrast between heat beneath the crust and cold above it could have produced strange phenomena. Subglacial lakes, frozen geysers, even pockets of supercooled brine where life found improbable shelter. Some scientists think these hidden environments were crucial. They may have preserved lineages of photosynthetic organisms that once the Thaw came exploded in diversity. All of this began from a few small changes in how the planet breathed. It's humbling to think that a slightly different tilt, a shift in landmass, or a slow drawdown of carbon dioxide could transform an entire world. But that's the story of Earth. It has always been sensitive, reactive, and capable of reinventing itself. The ice that wrapped the planet was not punishment, not a final chapter, but part of a long dialogue between rock, air, ocean, and life. If you picture the Earth as a living organism, the cryogen was like a long, deep sleep. The heartbeat slowed, the metabolism quieted, but the potential remained. Underneath the frost, chemistry continued. Nutrients accumulated, gases shifted, and the stage was being quietly set for something remarkable to follow. The deep freeze would eventually give way to warmth, and with it, new forms of life that would shape everything to come. For now, though, we remain in that frozen silence, with ice covering continents and oceans alike. The stars above look down on a planet, unrecognizable, yet still familiar in its bones. The continents rested where they drifted. The magnetic poles wandered, and the air held its breath. In that hush, the story of life persisted, waiting for the warmth that would one day return. And that's where we'll stay for the moment, here in the quiet, before the ice began its slow, inevitable spread. In the next part of our journey, we'll drift back a little further to see what the world was like before it began to freeze, when seas shimmered and the first whispers of change stirred beneath the waves, setting in motion the chain of events that would wrap the planet in white. Before the world turned white, it was alive in a very different way. Not with forests or animals or anything familiar to the eye, but with movement and color at scales too small to see. The oceans were dark and greenish, filled with microscopic life forms drifting in the currents. They were simple but tenacious, the quiet architects of the planet's chemistry. For billions of years, these tiny organisms had shaped the air, the water, and the minerals beneath. They had no bones, no shells, no eyes, but they were the reason the sky was slowly turning blue and the seas were growing richer with the ingredients of future life. If you could have stood on a rocky shore in that time, more than 700 million years ago, you might not have recognized the Earth as home. The continents were arranged differently, gathered together in a supercontinent that geologists later named Rodinia. It stretched like an uneven ring across the equator, surrounded by a vast ocean known as Morovia. The air would have felt thin and raw, carrying a faint sharpness from volcanic gases. There was no grass beneath your feet, only rough stone, sand, and the occasional film of microbes forming a slippery layer where moisture lingered. The colors of the world were muted: gray rock, dark blue water, rusty streaks of iron, and the pale glare of a younger sun shining through a hazy atmosphere. The sun itself was dimmer than the one we know. Astronomers estimate that it emitted roughly 6% less energy than it does today. That might not sound like much, but over the vastness of a planet's surface, it made a difference. To keep warm, the Earth relied heavily on its greenhouse gases, chiefly carbon dioxide and methane. These gases trapped heat radiating from the surface, maintaining a climate that allowed liquid water to exist despite the faint sunlight. It was a delicate balance, one that had held for billions of years. But